Um, I don't know. I don't know. Sound is going a lot. Anyway, I'll stop messing.
Next, on my computer using the Arch installer script, the first thing to do after installing Arch Linux is to update the system by running a command in the terminal which fetches the latest package information and upgrades all packages. Next, it's recommended to install core package tools like Nano, Git, and other necessary packages for a classy experience. It's time to configure Pacman and Mirrorlist to enhance the package installation experience. First, you need to modify your Pacman configuration file by uncommenting these lines and adding this line to make the progress bar look like Pacman eating the dots. After saving the changes, update the Pacman by running this command. Then you will now see a color text and a Pacman progress bar while installing any package. If you face slow download speeds, you can update the mirror list with the fastest servers available. Install Reflector by running this command. Then create a backup file of the default mirror list. Then run this command to fetch the top 10 fastest servers, which will add them to the mirror list. Then update the Pacman by running this command. After running any command to install a package via Pacman, you should experience improved download speeds while installing packages. Setting up a desktop environment in Arch Linux can seem like a daunting task, but it's quite simple if you follow a few steps. Arch Linux provides several desktop environments such as GNOME, KDE, XFCE, and more, so you can choose the one that suits your preferences. For instance, if you want to install the GNOME desktop environment, start by typing this command to install the Xarec display server. Then type another command to install the GNOME desktop and display manager.
Mm.
Once you have installed GNOME, you need to enable the GNOME Desktop Manager to start using the GUI. To do this, type these two commands and you will be ready to use the GNOME desktop environment. You can also install other desktop environments such as KDE Plasma and XFCE using a similar command. For more detailed information on how to install a desktop environment in Arch Linux, check out the blog post linked in the description. Installing essential packages can greatly improve your experience with Arch Linux, and there are a few commands that you can run to add a Bluetooth support and install some useful tools. By running these commands one by one, you can easily add a Bluetooth support to your Arch Linux system. Now, once you have added a Bluetooth support, you can then run a command to install some useful packages that make your life easier. Now, these packages can include various utilities, tools, and software that can help streamline your workflow and make it easier to perform various tasks. In addition to installing these useful packages, It's also recommended that you set up a Java environment on your Arch Linux system. By running this command, you can easily configure your system to support Java, which can be essential for running various applications and software. All users with an AMD or Intel CPU should install the microcode updates to ensure system stability. In my case, I'm having an Intel CPU. I'm gonna run this command and replace Intel with AMD if you are using an AMD machine. Then update the grub by running this command. While using Pacman in Arch Linux, you may find that there are limitations on which GUI applications you can install. For example, popular user repository or Flatpak to install additional limitations on which GUI applications you can install. For example, popular programs like Google Chrome, VS Code, and TimeShift cannot be installed through Pacman. Instead, you will need to rely on the Arch user repository or Flatpak to install additional software. Yay is a popular R helper which simplifies the process of installing and managing packages from Arch user repository. However, it's important to note that Yay is not a part of the official Arch Linux repositories and is not maintained by Arch Linux developers. To install Yay, run this command to install some dependencies. Then clone the GitHub repository by typing this command. Then navigate to the Yay directory and run this command to complete the installation process. Once Yay is installed, you can start installing GUI applications. For example, you can search for VS Code by running this command and then install it by using this command. Likewise, you can search for VS Code by running this command and then install it by using this command. Likewise, you can search for and install other packages as needed. It's also recommended to set up Flatpak in Arch Linux, which you can do by running this command. It's time to install some useful applications that will enhance your basic workflow on Arch Linux. You can go ahead and install applications like Firefox, LibreOffice, VLC, GIMP, and Thunderbird by running a command. In Arch Linux, it's a good idea to have a multiple kernels installed as a safety precaution. If one kernel fails to boot, you can use another one to start the operating system. For instance, I suggest installing the LTS kernel by running a command, as it's generally considered to be more stable than the latest kernels. Additionally, you can explore other kernels like Zen and Hardened. TimeShift is a backup tool for Arch Linux that can save you from losing important data in case of system failure. It's very similar to Windows System Restore and Mac OS Time Machine. TimeShift allows you to take a snapshot of your current system and restore it in case of issues. You can install TimeShift by running this command and use it to back up your install packages, applications, and data, making it a valuable tool for software projects or experimentation with custom kernels. UFW, also known as Uncomplicated Firewall, is a security tool that can help protect your computer from network traffic and block malicious software from accessing your network via the internet. To set up a firewall, run this command. UFW allows you to have full control over enabling and disabling ports. For example, if you are running an SSH server on port 22, you can disable this port to prevent connections from remote computers. Preload is a daemon service that runs in the background. It analyzes the user behavior and tracks what applications are frequently running by the user. Now, based on this analysis, it predicts what applications the user might run next and fetches those binaries and their dependencies into memory, and hence increasing the startup time of the applications. You can install the preload by running this command inside a terminal. Once it's done, enable the preload service to run in the background. Now, this will speed up the app launch times. Some users on some specific hardware may notice a higher battery consumption rate on Arch Linux than on Windows. This could be noticeable on the laptops. The easiest thing you can solve this problem on Arch Linux is simply installing Auto CPU Frequency. Now, this is a very useful tool that actively monitors the battery state, CPU usage, and temperatures, ultimately allowing you to improve battery life without making any compromises. To set up Auto CPU Frequency, first head over to this link and copy and paste this line of code into the terminal. Once it's installed, change your directory to Auto CPU and execute this script to set up Auto CPU Frequency. Once it's installed, you can type this line to learn the usage of the command. Now let's go ahead and activate it to run as a daemon service by running this command. You can check the status of this service by running this command. And also run this command to see the real-time statistics of the system resources. And that's pretty much it. These are the top 10 things you must do after installing Arch Linux in 2023. If you have any suggestions or queries, do let me know in the comment section down below. Don't forget to check my blog post linked in the description for more information. Thanks for watching this video. This has been KSK Ryle. I will see you in the next one.
Statistically, 96% of the humans watching this video are not using Linux. And that's just like really sad because it's a superior free open source operating system, but only has a 4% share of the PC market. Luckily though, 96% operating system, but only has a 4% share of the PC market. Luckily though, 96% of the non-human bots watching this video are using Linux because it is the dominant OS on the server. If you're a programmer or developer, you need to know Linux. That's where your code will eventually run and fail, and if you can't SSH into a Linux terminal and fix it, you are screwed. In today's video, you'll learn everything you need to know about Linux by looking at 101 essential concepts over the next 10 minutes. If you survive until the end, you should magically grow a neckbeard and be able to technobabble like an Arch Macintosh user. Before one can understand Linux though, one must recognize what came before it, Unix, an operating system developed at AT&T Bell Labs in the 70s. Its development led to a standardization called POSIX, or Portable Operating System Interface, to ensure that different systems would be compatible with each other. Its influence remains strong today, with Mac OS, Android, FreeBSD, and most Linux distros being POSIX compliant. In 1987, an OS called Minix for academic use was developed, but redistribution of its code was restricted. This inspired a Finnish computer science student named Linus Torvalds to develop Linux in 1991. Importantly, it's free open source software licensed under GPL 2.0. And by free, I mean free as in freedom. It's free to distribute, modify, and make money off of. Now, what I'm referring to as Linux is in fact not an operating system, but rather an operating system kernel. It's written in the C programming language and is the black magic that sits between your software applications and the hardware. When you hit the power button on your computer, the bootloader, which is usually Grub, will load the Linux kernel into random access memory. From there, it detects hardware and starts the init system, which is typically a tool called systemd, although alternatives do exist. Once initialized, the kernel will start up applications in user space, which will typically bring the user to a login screen. As the user starts doing stuff, the kernel has a lot of responsibility. It allocates and deallocates memory for processes, and can even create virtual memory to use more memory than is physically available by tapping into your hard drive. Speaking of the hard drive, the kernel also provides a virtual file system to interact with files on different systems. The fourth extended file system is the most common default on Linux, but it's not the only option. The kernel also interacts with all these peripheral devices via drivers. Pretty cool, but you can't just walk up and mess around with the kernel, and that's because it's surrounded by the CPU's protection ring. At ring 0, we have the kernel with the highest level of privilege, while most of us normies in user space live in ring 3, with the lowest level of privilege. But often, you'll want to do something that requires access to the kernel, like write a file to the file system. And that's where system calls come in. In this C code here, you'll notice that I'm making a syscall to write, which will transition from ring 3 to ring 0 to output some text to the console. However, write itself is not a system call. It's actually a wrapper provided by glibc, which is the GNU standard library for C, and provides all kinds of wrappers for making system calls that can do almost anything on your OS. But wait a minute, what is GNU? It's pronounced GNU, and it's a project that predates the Linux kernel itself and was started all the way back in 1983 by Richard Stallman. It provides all the core utilities for Linux, which are all the software utilities that make the kernel useful to humans. The best way to start exploring these core libs is to open up the terminal, which is a graphical user interface that allows you to send commands via the shell. Now, they call